join our lecture. So maybe 1 minute more and I will start presentation. As usual, I will switch off my video stream because it's make the connections more stable, and I will present you what I have on my screen. So in a minute, I will start. All right, no newcomers, I can start. Welcome on the fourth lecture from the Information Systems Modeling. And what you can see on the screen is the part of our last lecture under which I show you the design patterns, some examples of the design patterns which are quite common and well described and used in object-oriented programming. I already told you about singleton in details, and I also describe you as several other patterns which are in common use in programming in object are common in object-oriented programming. So somewhere at the end of this presentation, I couldn't, how to say, discuss more the details of this slide. So let me explain what I mean showing this structures, this diagram. Namely, a part of design patterns which are used to build classes and to declare variables. There are also some other patterns which are commonly used in order to build complex applications. And if we talk about the architecture of the application, we can also talk about some kind of the pattern. Usually, the enterprise applications are built based on some layers. So the whole business logic, the whole application, the whole implementation is divided into the parts which can be implemented separately, and then they can be integrated through certain interfaces, through certain mechanism like the short variables inside a big application. So usually we talk about the client tier, which is part of the software which is running on the client side. If we are talking of web application, this is the web browser. Web browser is just a client to your web application. So web browser is was also implemented. Someone had to write the source code of this web browser just to run it afterwards in a customer computer. So client tier is a kind of the part of the system, and mainly it is web browser. However, also on the client side, there might be some additional scripts which will do additional logic. And there is a presentation layer. The presentation layer is something that is implemented just in order to deliver the views, the HTML documents to the client tier. And this diagram, you can see, has in it JSP pages, servlets, and other interface elements. This sentence, JSP pages, servlets, and so on, came from, how to say, the approach which was quite popular a few years ago, in which the HTML documents were prepared with use of Java Server Pages technology. So let me refer shortly to this technology. If you go for JSP, Java Server Pages, so you will find out that Java Server Pages is a technology which is used to program, to build the views for the client, just to prepare this layer, which is presentation layer. And there are some tutorials on it. As you may see, this standard has used some annotations. It uses some beans, and in general, this working with Java Server Pages was as a working with a framework. And there were some real patterns that should be followed in order to deliver HTML pages to the user. And some of them were discussed in the book Information Systems Modeling. I will find out. Okay, on this one. So maybe some of you already looked at that book. It is available on the in our digital library, and this was the base for that course some years ago. And as you may see, the book is divided into two parts. The first one, which is oriented at building web application and on design patterns, and the second part is related to some semantic web technologies, WSDL, UDI. So the second part was written by me. However, in the first part, you will see that there are some chapters, some acapits or paragraphs related to just information systems, and these layers and structures of enterprise system are discussed in more details here. And as well, you can find out some design patterns described here with use of this class diagrams and sequence diagrams. As you may see, these design patterns are named as exactly in the same way as design patterns I described in my tutorial, for example, facade. However, the set of the classes which is here is a bit different than the set of the classes that I use when I describe this facade pattern. So the fact that you must understand is that design patterns are just the concepts of are the ideas how to solve a particular problem. And when you are solving that problem, you adjust that pattern to your needs. So these design patterns which are described inside that book are adjusted to the needs, to the additional use case, different than use case that was used by me when I try to describe these patterns in my presentation. So you can look at this description because it is quite nice. However, some of these patterns, like a service locator pattern, was designed using Java naming and directory interface, which is a part of enterprise Java Beans concept. And to understand how this pattern works, you need to understand how the particular layers of your application are working. So this presentation and business tier are linked, and the service locator pattern is just used on that bridge between these two layers, and it is described how it works and in that book. However, this is something that you can read. We are not using in our course Java server pages anymore. I switched to the other framework, which is a Spring and Spring Boot frameworks, and this is why the book is not obligatory for that course. It remains available for you. However, the parts which describe the architectures and the technologies are, how to say, a bit outdated. Okay, so this was like an introduction, but let me switch again to the diagrams. As you may see, these patterns, in fact, or this architecture, in fact, could be drawn also in a nicer way, like here. And there, some years ago, also there was a concept of Java Enterprise Edition. Java comes in two flavors: Java Standard Edition and Java Enterprise Editions. But it was when the Java was in the version 1.8 up to 11. However, starting from 11, the classes that are a part of Java Enterprise Editions were removed from the JDK and are developed separately. So you can find out books about the Java Enterprise Edition and about enterprise beans and about enterprise containers. However, these technologies still exist, but are developed separately now from the JDK. And it must be, if you want to use them, you must work with the Maven projects, and you need to adjust some dependencies in your projects in order to use this technology, use these concepts. Okay, so more or less, this is what I wanted to say. If you are working as a client, you are sending the queries to the Java, to the server, and if this server works in Java Enterprise Edition, it means that you have here some components, Java beans, which interact with the Java server pages servlets. And the servlets were these parts of that application that sends back to the user HTML document that could be displayed on a client window inside the client browser. So this was more or less how it was implemented. And however, nowadays, there are a lot of different approaches. So the server side, which usually is implemented now, has on its site database. It has a web server. To program server side, you must know some programming languages, web frameworks. So this is the set of technology stack that is needed to implement server side. And the client side, it means that part which interpret the incoming HTMLs, maybe with embedded JavaScripts, is a client side, and you have here some names of the technologies which should be known to the implementator in order to build the client side in a proper way. So we have here JavaScript, CSS, HTML, and some other libraries that might be native for a mobile application, like some particular libraries used in Android or iOS or other mobile system. So this is the web technology stack. As you may see, it is quite large. Under this course, we will, how to say, consider some parts in between server side and the client side. So we will talk a bit about JavaScript, HTML, and we also talk about web server, database connection, some programming languages. So this is a good base to start my second presentation, which is just on the available to you on my web page. I mentioned in that presentation that in fact Java JDK already was implemented with the use of some design patterns. So it is easy to spot, maybe not so easy, but if you look carefully on the classes that are available from the JDK, so you'll find out that we have their singletons. So if you ask your system for a runtime using get runtime method, you will get singleton. Your application runs within one environment, and that runtime it will be singleton given back or delivered by calling that get runtime issue. If you want to get the desktop of get security manager, you can also you will also get the singleton that was created, that was installed in the scope of your Java application. There are abstract factory, there are factory methods. So really, all these patterns which were declared by the Gang of Four are used inside implementation of Java SDK. So the list of these patterns is long, so you can go through it and verify whether I am right or not. If you would like to see it in details, so you can go always to the Java where it was lib src zip. Who of you ever opened that file? Are there any brave persons who opened that file? Inside this src zip, you have all the classes which are used by the Java JDK as in a source code. So let's see whether we can find out some interesting things. For example, Java util observer. Okay, so let's go Java, because this is divided into modules. Telling the truth, I am not sure in which module this package will be. Anyway, let's go to the Java base and Java, and let's see common classes. And as you may see, here is, for example, what would be interesting? System class. Okay, quite famous class. So here is the source code of this system class. Source code. If Java is, you can compile your own SDK, your own JDK. It's possible, and if you do this, you will work with source code of your Java classes. Some of the classes, it is interesting. In order to compile JDK, you must to have a Java compiler already in your system. So there is such a nice dependency to compile a JDK of the higher version of Java. You must to have a compiler of Java of which is a lower version of it. So lower version compiles a higher version, and this in a recurrent mode is developed up to the most newest one. most newest version of JDK. So as you may see, there is a system, right? System class. You can see there are some security manager, and a security manager, once it is set, it is stored inside the variable, and there are check permissions. So it is quite interesting to see how the JDK is implemented. It's interesting to see how the documentation in Java docs is prepared for that classes. So it's good point to compare your code with the code which was designed by the Java implementators. So this is a good point to look from time to time inside that source code, just to check how the designers of JDK solve particular problems. So this is what I wanted to show you. And going back to my presentation, so you can find out all these classes inside the SRC zip file, and you can check whether really the design of these classes follows observer pattern, state pattern, strategy pattern, and so on. These patterns are commonly used, but you can find out also on the many portals some comments to anti-patterns. Even I delivered you the link to such a web page. So let me go there. So this is a blog in which someone has discussed anti-patterns. Anti-patterns, these are, how to say, commonly used approaches to solve some problems. However, these approaches are wrong. It's not as it should be. So anti-patterns are just the wrong patterns. And even there is a book, Anti-Patterns, which discuss such bad behavior in a programming. As you may see, here is example what is bad and what is good. If you work in particularly with strings in Java, so this class is a class that holds a list of characters, or the string of characters. And if you want to build a longer string, accessing to it new parts, so mostly programmers which are not well educated just concatenate one object with the other object using plus operator. And in fact, in that line, I have already one object, two second object, and the third object that will be created every time you repeat this loop. So in fact, such a way of creating the strings is wrong, because the number of objects which should be allocated on the heap and then removed by the garbage collector is it's getting enormous. So it's not a way, it's not correct way of dealing with the strings. The better way is to use a string buffer. The string buffer is a class that holds inside the table of characters, and this is the only one object which is created, which can be used to, how to say, enlarge this table which is held inside that object in order to attach to it a new characters. So instead of building new strings every time you repeat a loop, so you are not building a new string buffer object, but you append the characters to the existing structure. So this is much more efficient. and it is better optimized by a just-in-time compiler which works in Java. So such patterns, such anti-patterns sometimes can be detected by the tools which check the how to say, the correctness of the source code you are writing in Java. Last time I showed you, maybe I will repeat this today as well. So let's go to the development and not here, to the IBM. I have a software designer, the Eclipse version of delivered by IBM, and on this Eclipse I have some plugins which makes me which delivers me some additional functions, and I want you to look at the how to say, the results of analysis of the source code inside the tool. Rational Software Architect Designer is something that you can download for free. I already told you during the lecture that there is an academic initiative and you can apply for the license. After applying, you can use this tool for free. And what I have here the class, and I can, where it is, TTT, okay. So I can go to that class and I can run software analyzer on this project. So I am running the software analyzer and I can see that the software analyzes tells me about some problems so let me like here always this comment means that inside my class I did not provide Java docs. Okay, so this is wrong. This is not correct way of writing Java programs in order, especially when these programs are used by other developers. So this is in general comments that Java docs are missing. Moreover, here it suggests that always declare method parameters as final. So in fact, when you run public static void main method inside your class, the common pattern is without using the final keyword. However, some of the methods you declare as a static. In general, if you declare the methods which use attributes, it's good to declare also the attributes of these methods as a final, because in that way you will make then access to these attributes to the Lambda methods inside your application and so on. So as you may see, there are many supported information which are not normally visible when you run just a designer, your IDE, and the analyzer of your syntax will not normally display this comment. So you need to have additional tool. In that tool, you can also find out that inside your source code, you have some packages, classes, methods, and that source code can be analyzed using some metrics. The metrics which are declared here, like basic cohesion metrics, the complexity metrics, and dependency metrics, These are metrics designed in order to compare one source code with the other source code. These metrics just deliver the value which is a number, and having the numbers you can compare different sources. If the complexity matrix is large, it means that your source code, your application is built with many dependencies. If your methods are mostly static, if they are not how to say, they are not dependent on each other, some kind of the metrics will show you that it is really that case. So let's see, for example, health state metrics. So you can see that there it is the correct one. Yes. So this matrix just discuss or counts the number of distinct operators, total number of operators, total number of operands. So whenever you are implementing some algorithms, this matrix will count how many times you use particular operators and how they are linked to each other. Okay, so how complex are your computations implemented in your source code? So this matrix is in general used to measure the complexity of the program without running the program itself, right? So higher Halstead complexity measure, more complex is your source code. So this is also a way by which you can check if your program is very complex or not. So these matrices are calculated by this tool just in a very simple way, and they display to the programmer just informations. Sometimes if you if you are the owner of the software development company and you have the workers, and these workers solve you the problems in two ways, so you can evaluate which one is better, even not running the programs, but analyzing the different matrices which can be calculated based on the source code delivered by these programmers. So there are also some other interesting tools which are embedded in this designer. For example, this designer is able to detect the design patterns which exist in your source code. So let me check whether this whether this tool is able to detect that I am working with the facade pattern. So let's start again. Okay, Java architecture. Okay, so it recognizes, in fact, that I have a computer facade pattern inside my source code. Okay, so this is also interesting. I don't know how they did it. They detect the design patterns which exist in my source code, which are architectural pattern and system patterns, and it's how to say it's detected inside my source code. This is also nice. You can check whether your programmers are really using particular patterns or not. Right, so this is the introduction, right? There are several tools by which you can check the correctness of your source code, whether that source code is based on design patterns, and you can calculate the metrics of this source code as well. However, this analyzer, as I said, is not a free tool. You need to have a license to use it. Moreover, if you are working with software analyzer inside Software Architect Designer, you are limited because this software analysis does not recognize a new, how to say, language features which were introduced in Java JDK 11 and above. So it works well up to 1.8, but higher version of Java language are not supported. Maybe, and there will be, or they are already some updates, but the version I installed on my computer is not handling well this Java constructs, which comes with newer version of JDK. However, this software analysis is just a tool to analyze the source code. However, you must build that source code using some construct of the language. And one of the very, how to say, often used approach or often used feature of Java language are annotations. Have you heard about annotations in Java? Right or not? I'm sure that you have heard. But have you ever implemented your own annotation? Hello?
Sir, I've heard of it, but never implemented it.
You never implemented. Yes. So let me refer for a minute how this annotations works. So usually when you're implementing your own annotations, it looks very, very simple. You declare something that is like an abstract interface, right? You put it in front of interface keyword, you name that interface like my annotations, and inside curly braces, you declare like a method, some abstract methods, right? It looks like a declaration of the interface. This is like a method, and the method returns some value. So the key point is that the data types you are using inside the declaration of these methods are common Java types, like string, int, long, and so on. Don't put here any custom types, custom data types, because this will be not handled. So what we have here also, the annotation itself can be annotated, and there are two annotations which are needed. One is a retention and the other is a target. Retention annotation is used to say where these annotations may appear. So the retention policy can be runtime, class, or source. If you put retention policy to this as a source, after compilation of that annotation, the class which will be annotated with it, in fact, in the bytecode will lose that annotation. Annotation will persist or will remain only in the source code, not in the bytecode. If you declare that retention policy is a class, it means that after compilation, the annotation will be attached to your class and will be preserved inside the bytecode of your compiled class. However, there is no guarantee that this annotation will be loaded by the Java virtual machine and will be available at the runtime or inside your application. So to make them available under the runtime, so put retention policy as a runtime. That means that the annotation when it is used will appear in the source code, will appear in the bytecode of the compiled class, and will appear in the virtual machine once the class annotated with that annotation will be loaded by the virtual machine. So this is, how to say, the simplest annotation you can create. This annotation, after such declaration, can be used. By the use of that annotation is a bit different than the declaration. If you are working with annotations, all these methods, which were, how to say, declared as a abstract method inside a special kind of the interface, now are accessed by this assignment. This assignment is like a declaration. What is the type you're returning from these methods? So name should return some name. Value should return some value. Do you understand? Here is the abstract methods declaration. And when you are using declared annotation to annotate some parts of your code, you deliver the value that these methods will return to the runtime. So some name will be returned by the name method, some value will be returned by the value method. All right. So in the other part of the annotating of particular custom annotation is the target. The target annotation is used to say to which part of the source code this annotation might be assigned to. So if it is a type, it means that this annotation can be attached to the class. If you say that annotation is a field, the target is a field, it means that that annotation can be attached to the field of the class, and so on, right? It is easy to spot which part of the class, and in general, which part of the source code can be annotated with that annotation. So here I have type. The definition of my annotation is with the target, which is a type. It means that I can put my annotation to annotate the class. So what it means, put an annotation to annotate the class? It means the annotation should be just before the declaration of the class. And it is the case I am showing now. My annotation is placed just before the declaration of my class. So once this annotation is attached to the class, I can use that annotation inside my runtime, inside my algorithms. So that you can discover what kind of the annotations were attached to the class. This is done through reflection. So you can ask the class for its class. So the dot class, which is shown here, is a reference to the object which represents the class and all its details. So here I acquire the reference for such an object. That object can be how to say, search for annotation. That object has a get annotation method. This get annotation method will retrieve from inside your class definition all the annotation which were placed in front of your class. And having that annotation, you can go through them, and if one of this annotation is instance of my annotation, then you can access these methods. Can you see my annotation.name, my annotation.value? This is like a function call, right? And that response or the value returned from that method will be exactly some name when I call name, and will be some value when I call a value method. So I want you to understand that annotations are like a metadata which are glued or connected with the element they are describing. This is not any kind of the code which should be executed. No, these are just metadata which are hidden inside your source code, and you can retrieve this metadata and you can do some actions based on these annotations. And one remark at the end: annotations are attached to the fields, to the classes, but not to the instances. Do you understand the difference? Annotations are attached to the classes, to the fields, to the attributes of the methods, but not to the instances. When I am running a reflection, so I am working on an object which represents a class. So it means not instance, but only class. So every instance, which is an instance of particular class, in fact, if I ask that instance for its class, will return the same annotations values. So this is how it works: simple declaration of annotation and simple use of that annotation. Why so many words about these annotations? Because during the labs, I told you that I showed you that in our examples, I am using Spring and Spring Boot frameworks. So in general, Spring framework is a Java framework that does a lot of things. It solves a lot of problems. It can be used for testing, so it delivers the mock object and test framework and MVC test, web test client. So it has a lot of tools for testing. It has a lot of tools to access data storage. So there are JDBC or and transactions and so on. It supports servlets. It supports integration. It supports even various languages in general. So the framework, how to say, is very comprehensive and has a lot of parts. And if you want to play with that framework, you can select during your where it is. Let me check. Not here. Okay, you can organize your project just before running it. So how it is done? There is such a tool like a Spring Initializer. Spring Initializer is the, how to say, the tool in which you can specify that you would like to play with a Spring framework, and you can also attach which version of the Spring Boot you are going to use, because a Spring and a Spring Boot are two things that are related. Spring in general is a framework. Spring Boot is like a extension of this Spring. It is more automatized. It has more automation inside. So if I want to use Spring Boot version 2.6.4, so I can select it. I can declare attributes for my project. These attributes later will be used in the Maven that will be produced by my initializer. So I can say that I want to my project to be compiled and packed into the jar file. I can specify which JDK I am going to use. See, there is an 8, 11, and 17. Why only these three numbers, not any in-between numbers? Because these are a so-called long-time support version of JDK. And this is also a good custom whenever you are working with Java, just to work with stable version, with the versions that are supported for a long time. So 11 is a long time support, and 17 JDK is a long time support. It should be maintained for a longer period than the other version of JDK. So I can add also dependencies. If I want to play with a Spring Reactive Web, so I can attach this. If I want to work with REST repositories, I can attach dependency. If I want to work with Spring Web Services, I can add dependencies, and so on. So all these dependencies you can see here are divided into groups, and you can Spring Data JPI, you can select them according to needs. So what I have here on that slide is the architecture for Spring is just the depiction that inside that framework, some of the parts were already organized with some artifacts, some groups. And these groups can be attached as dependencies to your project in a separate parts. So this is what I am doing here, right? I am accessing a particular artifacts, particular components of the framework to my project. After having that declared, I can generate my project. I can go to the demo zip, and you will see if you open it with from zip tool, that this is a POM which was prepared with this all attributes that were on Spring Initializer, and I have all these dependencies which I declared to be included inside my POM, and so on, right? And some plugins which are used in order to build my Spring Boot application. So this is how you can start to play with the Spring Boot framework. And this framework also assumes that your project is organized in a certain way. So there is a SRC, there is a main Java, and inside this main Java folder, you have the subfolders for the packages you are implementing by yourself. If you are going with to add the test to your project, these are in the test folder. So the project structure, these catalogs are just standardized. Most programs that are written in Spring Boot are organized just like there. And there is also a resource folder, and a resource folder is for resources, something that configures, something that delivers a configuration, and something that delivers static part like images, icons, and so on. These things should be delivered inside the resource folder. Okay, so this is a short remark how to start with the Spring framework and how to build your own application. So as I said, Spring and Spring Boot are related. Spring is a framework, and Spring Boot extends the Spring framework, eliminating and the boilerplate configurations. It allows you to make this configuration much easier than in Spring. Because in Spring, the developer must set up the Hibernate, Entity Manager, and so on. Many setups has to be done manually, and each sub-framework, which is here like Hibernate, Entity Manager, has its own configuration files. In the Spring Boot, you can configure everything in the same manner. Spring Boot allows you to do that configuration by using external file, using property files, using classes with annotations, and I think this is the all. So let me show this here, that configuration in a Spring Boot of particular parts of your application can be done in XML as Java annotations. They can be also declared programmatically as in Java code, and that's it. What's more, it is also necessary to understand that Spring Boot applications work in the so-called Spring container. So whenever you declare, whatever you declare as a controller or as a bean or as a service or any other, how to say, active component inside your Spring application, this part which was annotated will become an instance inside the Spring container. The Spring just starts its execution, where it is according, maybe this will be good. Okay, so the Spring application, once starts, it creates the container, and this container goes through several stages. And at the first, it instantiates some beans. It populates properties. If there is a declaration of set bean name inside the particular beans, these methods will be called. Then set bean factory will be called. Then pre-initialized bean post-processor will be called. Then initializing beans after property search will be called. Then custom init method will be called. After that, post-initialization bean post-processors will be called. And finally, your application will be ready to use. Your beans which are existing in your application will be ready to use. So what I want you to understand from the chart is that applications which are run in a Spring Boot are applications that are running in a container, and that container has its own life cycle, and this life cycle has several stages, and in these several stages, particular parts of your declaration, particular methods of your beans are called in certain order. Okay, so let's go to the Spring Tool suite, which I already showed you during the labs, and which was used by you, maybe even not knowing how that Spring Boot works. So I have a simple beans program. Okay. So this is a simple Spring application, and that container I told you, which can be in which your beans will be existing, can be loaded by various means. You can initialize your application based on particular class. you can initialize, okay, this is application context you are using can be initialized from the class. Having that context, inside that context, you can access the beans that have been declared in it. So maybe this is a bit complex, I see. So maybe I will show you this example. This is a simple one, which maybe will be more will be easier to read. So I have a greeting app. It has a main method. So as any Java application, so the whole execution starts from the main entry. And inside that main, I have something that is called application context, right? And this is the container inside which all this Spring container starts to live. The whole particular steps of its life cycle will be executed. And this application context is loaded from the, in that case, from the XML configuration. So you can go to the configuration where it is. It should be in resources, and here is the greetings. So see what I have here. Inside that specification, I have a section beans. Inside the section beans, I have a bean, and I have a declaration that I have a class greeting service, and I have this greeting service will be identified by the greeting service. Okay, the instance of that class will be identified as a greeting. And inside that greeting service, I will have the property name. I have the property greeting too, and the value of that property should be welcome on laboratory exercises. Okay, so this is the configuration that specifies me that inside my container, I will have the bean greeting service, which will be created based on greeting service class, and this bean will have the property greeting too with the value welcome on the laboratory exercises. If I look on my application, I can see that from that context, I can get just that greeting service bean using getBean method. And having greetings method, I can call say greetings on it. What is this greeting service which I'm using in front of getBean method? So this is the interface. Inside that interface, I have say greeting method. So what I am telling in my application that my context will deliver me a bean, and I will treat that bean as a bean which delivers me greeting service interface. And in fact, it will be delivering that interface because greeting service, let me refer again, is something that is the instance of a greeting service to class. And this greeting service to class, where is the testing? Okay, greeting service O2 implements that greeting service interface. So everything is correct. Okay, so going back to that app, so having that greeting service, I can call say greeting on that method. So that method, look at it. This is the definition, but implementation where it was testing. Say greeting just should print out on the screen greeting, but the greeting is declared here as a field inside my class. I have set greeting O2 method, which when gets some value, it will attach to it O2 text. So again, greeting service is a class that implements greeting service. It has the private field greeting, and this private field can be set using set greetings O2. And this set method just plays a text delivered as an attribute of that method plus O2 at the end of that greetings. Okay, so this is the implementation of my greeting service. But when I look at my application, I cannot see anywhere that I am calling this set method, right? I am retrieving the bean and I am calling say greeting method and it will work. Why? Because inside my configuration, I said that I wish to run set method on my bean and I want to deliver welcome on laboratory exercises as an attribute to that method. Okay, so that part I showed you is something that is called in that framework dependency injection. So let's come back to my presentation and let's talk a bit about dependency injection. In a traditional way, whenever you want to initialize any field, so usually this initialization is done through constructor. Inside that constructor, you initialize the field. However, if you would like to be compliant or if you want to use dependency injection, so instead putting this initialization inside your constructor, you just can declare your constructor with an attribute which will pass the data into your private field. Okay, so here I have a constructor that does not takes any attributes. Here I have a constructor that takes one attribute and passes it inside the instance. This is what is called the injection by the constructor or constructor-based dependency injection. But it can be also done through setter-based dependency injection. If I want to create an object, I can create it using a non-argument constructor, and then I can call setItem method on that object, and I can pass the value I want to modify just into the set method. So in the Spring Boot, anything that is annotated as a bean is a method that delivers just instances of particular class. Item 1 is a method that will create for you instance of item class. Here I have also a method which is annotated as a bean. It means that that store method will create inside the Spring Boot container an object which will be an object of store class. And this return new store item, you can see that will create my new object and will initialize that object through the constructor that takes an attribute. and this attribute will be delivered by that item one method, which will be another bean. Okay, so you can see I have several methods which will deliver me instances, and this method will be called automatically by the Spring Boot framework. The Spring Boot framework, once it initializes its own life cycle, it will build all these beans. So the initialization, instantiation of the container can be done either as it was written in the configuration file in that XML I showed you before, or the initialization can be done through annotations. You can say that one of the classes you are in your project is a class which is a configuration, and inside that class you declare some fields as a beans, and this some methods as a beans, and these methods will be called when the application starts, and will create all these instances. So instead of initiating inside the context the particular instances according to the description of this configuration, you can initialize them, but using annotations. So here is just part which could be also placed inside app-config. Here is the setter-based dependency injection and the fields-based dependency injection. This is maybe important to us because I have the annotation auto-wire. Whenever you have an auto-wire inside your Spring Boot code, it means that the framework must itself look through all the beans which are declared in the configuration, either in this configuration file or by using beans, and it should find a method that returns item data type, and it will call that method and will initialize that item using that method. So whenever you have an auto-wired annotation in front of some fields inside your source code, it means that that item will be initialized using some methods or how to say configuration which will deliver a proper instance of required at that place. It is also worth to note that beans which are built inside the Spring container normally are singletons. So they are created once, and once the application starts, and they can be used many times. So whenever there is a need to access that item, this will be always the same item. It's possible in a Spring Boot framework to create beans using a factory method. However, this is, how to say, more complex, and I will not discuss this just now. So, as I said, the construction of the bean inside the bean container is done within the process of life cycle of your Spring Boot container. Container finds the beans and instantiates the beans. Using dependency injection, it populates all the properties as specified in the definitions of these beans. If the bean implements bean-aware interface, so the factory calls will be issued set bean name, and so on and so on. So this is the life cycle, the consecutive steps which are executed by the Spring Boot. And Sprint and Beans destruction also follow some rules. And on the diagram, you can see that when the application is shutting down, so the disposable beans method destroy is called, then custom destroy methods, and finally application stops. So maybe the initialization, as you can see, is much complex. You might have much more steps. The closing application is a bit shorter. It has less steps in its execution flow. All right. So as I said, Spring uses a lot of design patterns, and it uses a lot of annotations. I listed in my presentation many of them, but most common used annotation you will see in your source code are just this bean annotation, this auto-wired annotation, maybe configuration and the component scan. This configuration and component scan are needed in order to configure your Spring Boot application properly. Okay, so let's switch to the source code. So if you go to the student app, which was generated by the Swagger CodeGen, you will see, for example, that I have some annotations here. These annotations, like validated, generated, and so on. Okay, this is maybe not correct part I wanted to show you. Let's go to the main class, Swagger to Spring Boot. So this is the main class of my generated source code. Look, this class is annotated as a Spring Boot application. If you have several classes in your project, so and you ask to start your project, so this Spring Boot application annotations can be used by the framework to recognize that really this class is an entry point for the Spring Boot application. It has a main, and this main just construct Spring application, and the context in which we work is just the Spring Boot class, and we run the run method of it. Inside that run method, we just consider whether some attributes were delivered to my application from the command line. If so, I can do something, but there is no need to do anything. And look, this class is a command line runner. So that application will be run from the command line. You will see that in a Spring Boot, that application can be also declared in different way. However, I will not discuss now the meaning of these classes, just to let you know that because this Swagger to Spring Boot application implements command line runner, therefore I can just create an instance and I can run it, and my application just will run and execute all its life cycle. Moreover, I have a component scan in front of my application. What is this for? So I pass the Swagger to Spring Boot class as an attribute to my Spring application. And after passing that, this Spring application implementation will extract the component scan annotation, will find out that the dependencies or the other beans which are needed in order to run that application are spread in packages: Java IO, Java IO Swagger API, IO Swagger configuration. So the container, that Spring Boot application will discover or will check all the classes which were loaded in these packages in order to find out whether inside there are some other beans already declared. So let's see IO Swagger. Where I am, IO Swagger. So I have another class inside that package, but it has no Spring Boot annotation. So this is not, how to say, very important. In my components card, I have also IO Swagger API. So let's go to the at first for the API description. And I have here student API. I have here generated and validated annotations, and I have also operation, security, and request mapping, and so on, API response. So in fact, here are the annotations like request mapping, which are used by the Spring Boot. Okay, and this is just the interface, but I have also the controller, and this controller itself has a REST controller. Okay, here we are. REST controller annotation means that that class is a bean, but of special meaning. It is a REST controller. That part of the application will be a part to which a web application server must deliver a result of the calls. Okay, so still the REST controller is something that will receive the request from the web application server, which is embedded inside your Spring Boot application. So this is known from that REST controller. And how the Spring Boot application finds out that component, because I said in the component scan that scanning must be done on all the classes which are in that package, and the Spring Boot will find out that my implementation is a REST controller. It means this is a bean which will be created in order to serve some responses to the incoming request. Moreover, I have here auto-wired. If I have the auto-wired, it means that Spring Boot, when it starts to create that object, will inject here something that is a instance of the student service class, right? Auto-wired. It means that magically Spring Boot will insert here, once it will create an instance of that controller, something that is an instance of the student service class. And student service, as you may see, is declared here as an interface. It is just interface, and here is the class that implements this interface. See, this class is annotated as a service. If anything is annotated as a service inside your source code, it means that this is a bean. Again, something that a part of your solution that will be created, will be a singleton, and the meaning of that bean is that this is a service. It will be used to deliver some methods to other beans. And as you may see, are there any constructors inside my student service input class? Can you see? There are no constructors, right? declared. If I want to work with the beans inside various frameworks, so it is common to deliver non-argument constructor in that class. So if I don't specify any constructors, the non-argument constructor is delivered by the compiler by default. So here is a service. So my Spring Boot framework, whenever finds out in the controllers auto-wired field, and that field is something of the specific is an implementation of specific interface. So the Spring Boot will search for the classes that implements that interface and will inject instance of that class in that place. In particularly, in the set of my classes I have in my solution, I have only one class that implements that service, and this implement that interface student service. Moreover, this class is annotated as a service, so it means it will be a bean, it will be a singleton that will be created inside my framework. And I have again something very interesting, another fields which are auto-wired, and these fields are declared as auto-wired, so it means that once at the moment the student service instance will be created, Spring Boot framework should also inject me the instance of the students repository, where there are the students repository. This is the interface, but I have only one class that I have even no class that implements that repository, right? I have only declaration. I have no implementation of this repository. So how it happens that anything will be injected inside my class? Do you understand the question? Here I have auto-wired, okay? I have here the declaration of the field students repository, okay? And I said here that the Spring Boot framework should find out in the set of the classes in the selected packages that class that implements that student repository interface and should create the object of it. But I have students repository only declared as a interface, but I have nothing here that implements that interface. Do you understand? So the Spring Boot does it in a very intelligent way. So inside my POM, I have the declaration that I am using SQLite, okay, Spring SQLite database, and I am using Spring Data JPA, and I am using Hibernate. In fact, inside these packages, which are declared as dependencies, there is an implementation of the repository, and this implementation again will be, how to say, injected with the classes from the SQLite. So in general, Data JPA will use Hibernate, and Hibernate will use the implementation of some clients which are clients to SQLite database, and finally I will got the connection to my data store, to my testDB file through the chain of such dependencies. So this is how it works. It's when you start for the first time how to say, the challenge with Spring Boot, this kind of the annotations, okay, and auto-wired and this transactional and service and so on might be very tricky to you. But what I want to say during that lecture is that everything which is here, which is in this Spring Boot, just relays on, let's say, very close, relays on the concept of the container. Container is something that collects beans and constructs beans inside that container, which are ready to use in your application. And this is done in an automatic way based on annotations. And annotations, in general, there is nothing, how to say, nothing mysterious in the declaration of this annotation. They for sure are declared in a similar way, like here, like here. Spring Boot just makes these annotations in its own definitions, okay, in its own source code. However, Spring Boot framework uses in its life cycle that kind of the reflection. It gets the annotation of particular classes. It finds out whether these annotations are instances of particular type. It retrieves the metadata which are assigned to the parts of these annotations, and based on what it retrieves, it behaves in a certain way. So finally, all right, your source code, which has these annotations, is interpreted correctly by the Spring Boot framework. In my how to say lecture today, I wanted also to discuss a connection to the database, but I looked at the watch and it is already after hours. I should finish 3 minutes ago the lecture. So I will try in 10 minutes up to 11 the short introduction to the how to play with the databases, okay? Because this is what is needed to implement the laboratory task. So here, let's start with a simple DB test Java, and I have here the demo, DAO pattern demo, okay? Here there are no frameworks. This is just pure Java programming with a pure Java classes. So I declared student DAO interface with some access methods that will retrieve data from my database from somewhere and nothing else, right? I have the implementation of that interface. Inside that implementation, as you may see, I am loading the driver and I am making the connections, and afterwards I am sending the request to my database, just pure SQL request, right? So this is how it is implemented. Very, how to say, this is JDBC connection to the database, and the simple programs just look like that. There is a driver load, then the opening the connection, then preparation of the statements, where these statements are prepared based on the SQL query, and after running that SQL query, like execute update, you can update the data, you can retrieve the data from the database, and that's it. So this is how it is done with pure JDBC driver and pure JDBC implementation. However, if you are working with more advanced way, you can declare this in use of annotation and with use of particular framework. So here I have the example. I declare classes which are annotated with entity annotations. So this entity annotation, as you may see, is a part of JPA, part of persistent package. This is what was defined in one of Java specifications. So entity it means that this class should be converted into the row inside the database. And in which table this row may appear? It is in the table, okay? In this table, which is named address. I have ID annotation and generated value, which means that the value of that field, which with that annotation, should be treated as a primary key inside the relational database. I have generated value annotation, which means that database should assign the values for these keys in automatic way. So strategy generation type auto is just the declaration that these IDs should be generated in a sequence. And the other, there are no more annotations because this class is just a simple class with a simple primary key, and that's it. However, I have an owner. An owner class is a class which is also declared as an entity, but this class has its own ID as well. However, in that class, I also showed you that you can annotate a particular field with a column annotation. It means that the value of that field inside the relational database will be named phone_no instead of phone number. And I have also some more annotation. Join column, one-to-one, and one-to-many. Whenever in your schema of your relational databases, you have the entities which are linked each other with many-to-many relation, you must change this into one-to-one or one-to-many in order to make this schema working. Okay, so this is how you can say whether you have the one-to-one or one-to-many relation between different parts of your design using this one-to-many and one-to-one annotation. Pet is also entity, which should be stored in the pet table, and it has also many-to-one relationship, and this relation must link with the column owner ID of the other table. All right, so these are entities. I have also repositories, and as it was already shown in the student app, I have the address repository that extends CRUD repository. I have owner repository, which will be used to access owner data, and pet repository, which will be used to access pet repository and pet data. And I have just a simple JPA application. Look what I have here. It is again Spring Boot application. It implements command liner. Inside that application, I have some final fields: pet repository owner and others repository. And I have also a logger, which is used to log some information about the execution of my service. And I have also auto-wired. Do you remember what it means? If I have auto-wired, it means that my framework should inject pet repo, owner repository, and others repository into the constructor of simple JPA application. So I will not call myself that constructor. The framework will call that method for me, injecting the proper object into my constructor. And here is the main method, which will run a simple JPA application class. This is a standard. It will run that run method. Inside the run method, I will create a new address, new owner, and I will, using the repository methods, I will save this object in particular repositories. Look, I never called the constructor of the repositories, right? Can you see? There is no instantiation of this owner repo or pet repo or whatever. This will be initialized by the framework because I annotated my constructor with auto-wired annotation, and this repositories framework will find out inside my classes and will create the object. It will inject them into the constructor once the simple GPA application will be instantiated. So this part of the source code I am showing is just playing with the objects. I am creating the object address. I fill in that address with data, and I am saving it to the repository. I am creating the owner, and the owner is linked with that address. I am passing the reference to the address object to the owner entity. O1 instance, and the same to the O2 instance, and having these two instances, I can save them to the repository using save method, and so on. So final remark, I can run that application and I can see whether this application really will work. Look what I have in my application properties. I am saying that I want to display H2 console. I want to show all the requests which are sent to the application, to the database, and I want to access this console through web browser. And why H2? At simple student application, I used SQLite database, and in that project, I am using H2 application. So in my dependencies, I have H2 database artifact, which delivers me a different kind of database. H2 is an in-memory database, so it will be kept during the execution of your application. Once the application shut down, the database will be removed from the memory. It's possible to preserve what was the content of that repository into the file, but I will not touch this at the moment. Okay, so let's run this application as a Spring Boot application. Okay, so because I said to debug all this information about communication with database, so I can see drop table address if exists. So my Hibernate will send to my database request to clear the database. Then we'll create the schema of the database. We'll attach the foreign keys. And after that, we'll insert into address some values. And next, insert into owner, into pet some values. After that, it will select from the pet some and from the owner table some data. It will query. So where it is just, these are just this save method. Save, it was the method that was persisting the object into the database. Next saves will store the owners into the database. So I can see here are the the results of issuing the save command. Insert into address, insert into owners, insert into owner, and insert into pet. Really, yes, I have two save methods inside my source code, and I have find all, and I will print the instances of the pet into log. So really, this method find all, in fact, will select pets, and because pets are dependent on owners, so it will also select on the owners, and these two requests will be sent to the repositories in order to deliver me set of the paths which I can then display on the screen. I can see this, I can connect to this database using HT console. So localhost 8080, maybe I will try this from the beginning, okay? Okay. I am trying to connect to this database. So here are parameters of that connection. This H2 console is delivered by the framework. TestDB is something that I declare as a database, standard SA user, and without any password. I can test connection and I can connect. After connecting, I have the access to all my databases, and I can also run the request to my database and see whether really the data were inserted into it, and they are. So summarizing, it was, I think, the quite hard lecture and a lot of information, but few of them are very important and I want you to memorize. So starting from the annotations, right? Annotations were introduced in Java JDK 1.5 and are used to attach metadata to the parts of your source code. Annotations are used by various frameworks, Java frameworks, and in particularly are used by the Spring framework, which is extended by a Spring Boot. Spring Boot is better organized. It means it gives the developer a chance to easier configure all the dependencies. And this configuration can be done through it can be done through XML file. So do you remember this context file? It can be attached to the classes by Java annotations. On that configuration can come programmatically. You can declare inside the Java code all these properties. So when you run with Spring Boot, you use dependency injection. And in fact, these dependency injections can be done based on the configuration, which is delivered in the file, or can be done based on the annotations which exist inside your source code. If you are working with a Spring Boot application, the use of annotation is the preferable way of delivering such dependencies, to implement dependency injection. And finally, there is a bean lifecycle. When Spring Boot starts, it instantiates beans and it destroys the beans according to the steps depicted on these charts. And in particular, when you are working with your web application and you are using Spring Boot, so Spring Boot gives you together with Hibernate mechanism which simplifies the implementation of the database storage. You can work using Java classes, and that instances of that classes will be converted into SQL request. But in order to make this conversion possible, you need to use repositories, and you need to use particular annotations on your entity classes to make the proper schema of your relational database. Otherwise, it will not work. So this is all from me today. Any questions? Are there?
No.
No, all right. For those who first accessed the Spring Boot and in general did not program in Java in advanced mode, so it might be really hard. However, I would like to make the things for you simple. Therefore, I delivered to you an example of students app in which you can see all this, how to say, parts of the design. I have a student app where it was student app. Okay. Inside that application, that the skeleton was generated automatically. I create a new package. Inside that package, I create services. Oh, sorry, I put services and the repositories. So maybe this is not the best name for the package, because I have either services and repositories. However, I think this is not a big deal. So I declared interface for the repositories, interface for the services, and I deliver the implementation of the services. There are two implementation, one which is in-memory store and one which is in database store. And I did it especially in order to show you that it's possible just to switch between the different repositories, but you need to a bit adjust the place in which this repository is injected in your application. Here it is auto-wired, means so the first class that fulfills the requirements of implementing the student's repository will be injected. So that's all from me. Application properties I already discussed, so on the labs, so nothing more to say. Thank you for coming. Please try to fulfill my requirements regarding the labs. I'm not asking for a big deal. I'm asking just to adjust a bit what you have already generated from you receive from Swagger Coder Gen. Try to on the next lab make an access to the database and deliver the views, the first view. So thank you again and see you on labs.
Thank you. Goodbye.
Goodbye.
Thank you. Have a good day.
Goodbye.